Hi students, Mr. C here at the Wood Shop, and I'd like to talk to you today a little bit about CNC machines and the software. So like right now, we're looking at the pieces to a wall cabinet that goes above a refrigerator and part of a kitchen cabinet. So come with me and I'll show you the CNC machine real quick. In the shop here, we happen to have a 4x8 machine with an automatic tool changer and a vacuum to hold down the material. Now this is our controller. I'm just going to kind of move this out of the way. Don't be distracted by that right now. We'll get to the controller in a little while. But here's all our tool holders, and then also these are all of our different vacuum ports. The left side, the right side, they each have 3 ports on either side. So that gives us all 6. So we can either turn on ports or turn them off depending on where we want the vacuum to be. On this machine, we have what's called a spoil board, where we can go ahead and cut into this. We still have vacuum. Yes, I will be replacing this very shortly. We just have one thing to run on this machine before we go ahead and start cutting out 4x8 sheets, pieces of material. Our spindle on here is an HSD spindle. It's a very, very good, powerful 5 horsepower spindle. The thing I love about this is if we run the RPMs at a very low RPM, we're still generating 5 horsepower continuous. So that's why I really like the HSD spindle on here. Here is our gantry crane, and then it slides back and forth. We have our vacuum pump in the back here, a Belkin, which is pretty much industry standard that you'll find in pretty much every millworking shop as far as on their CNCs. This happens to be a piece of medium density fiberboard, but the reason why I'm showing this to you is because our sheet goods that we cut are typically 4 foot by 8 foot in length or 48 by 96. And the thickness on these is 3/4 of an inch or 0.75. Okay, so that's why I'm showing this to you. Now what we're going to be making our cabinets out of is a high grade, cabinet grade 3/4 inch plywood. Yes, I know in the industry a lot of people use 1/2 inch, but we use the 3/4 inch because it's a stronger, more durable product, and we're not cheapening out on the people that are getting this product. So if you want to come with me, what we're going to do is I'm going to take you to the laptop. I'm going to show you the CNC software that we go ahead and we design all of our cabinets up in here with this particular software. Now this software was not designed for cabinets specifically. There are a lot of different cabinet software products out there that you can purchase for the CNC machine, but I found that for us here in the shop, a very user-friendly CNC program is this one made by this one company. I'm not going to name it by name just because they're not endorsing us and I don't want to mention their name. But when you go ahead and start a new program, let me just do this. I'm going to turn this off. I'm going to close this out. When you open up the file, this is what it'll look like, okay? And then I want to create a new file. So like I'm going to go ahead and on this point right here, I'm going to click this portion, create a new file. Now the most important thing is this setup. If you don't set up your material properly, it's going to be very difficult for you to go ahead and get a finished product that we're looking for. So the very first thing is we have single-sided. The width of the material, or the X, is 48. The height, or the Y, is 96 inches. And the thickness, which is the Z, is 3/4 of an inch. So these are your Cartesian coordinates. Now remember, your geometry class, you actually do use this stuff. So your geometry teacher was kind of on the money. But here we go. Now on the Z, this Z positioning, I want to have the red dot here on the top of the material because I want to register the bit to start cutting at the very top of the material. It's less confusing when you're setting up or setting parameters for cutting if you do it this way. Now once I've done this, now the X and Y, you want to have this in the lower left hand corner, especially when we're working with full sheets. I go ahead and press OK. Once I do that, all my design tools show up here on this side. Now on this side, if I come over and I click on the tool pass and then I pin this pin down, it'll leave all my cutting tools or my tool pathing tools all here on this side. So I know that right here, this is all my cabinets for this kitchen. Now the first kitchen cabinet we have to do is a 36 by 16 by 12, okay? Now, that tells me the dimensions of the actual project or that particular cabinet. So what I want to do is I'm going to come over here and I'm press the rectangle tool, draw a rectangle. The beautiful thing about this is I can go ahead and position my material exactly where it's located on the machine. So I want this to be 0.0 on the X and Y for my very first piece. So that's where it starts. Now the width of my part is I'm going to go ahead and design out a side to my cabinet, my upper cabinet. The width of that cabinet is 12 inches, which is industry standard, and the height on this one happens to be 16 inches in height. Okay, I'm going to go ahead and create that. So now you can see over here, it created this box right here, which is just exactly what I needed. Okay, now I'm going to press create so that way it's no longer highlighted. Now I have that, but now what I want to do is I want to create all the different tool pathing or the different tool paths that I'm gonna have to create on here, the boxes essentially. So I'm creating all the joints so I can hold this together. So since I can be so accurate with this, is what I'm gonna do is I'm gonna take the X is going to go at 1.25 and the Y is going to remain at 0. I'm sorry, the X is going to remain 0 and that Y is the height is 1.25. Because what I'm going to do is I'm going to set up my dado for the very first cut or the very next box. Okay. Now the width of it's going to be 12 inches because I want it to go the width of the cabinet, but the height of it is the same height as the material so that way it can register in, which I will show you in detail later. So now what that just did was it created this little line right here. So what I'm going to do is I'm going to zoom in on this. Okay, so you can see this a little bit better on the material. I'm going to hit close. Now I'm going to press the box again. Now I need to have a dado exactly at the very top. Now, because the material is 3/4 of an inch thick, I need to subtract 3/4 of an inch from the 16 inches in height. So on the Y, I'm going to have this set at 15.25. Okay, and then when I press create, this box appeared here for the rabbit at the top of my cabinet. All right, now I have to create a rabbit in the back of the cabinet, which would be on this side right here, for the backing of the cabinet to go. Now I know a lot of industry people or a lot of cabinet companies build their cabinets with 1/4 inch backings. I don't like to do that because I don't think it's strong enough, and like I said, since we are a school, we want to teach you how to build something that's going to last for a very long time. So why not build it the way that things were built when I was in high school, which, you know, was in the 90s, where we actually built things without considering only thing was cost, and also the only thing that really mattered was how much profitability we had. That we built things the right way as far as I'm concerned. So I know that's a bit controversial for some people, but too bad. I'm teaching students and I want to teach them the right way, not the one that's going to make them the most money and profitability in somewhere else. And I don't want their cabinets falling off the wall. So on the back, I'm going to have to go ahead and create a rabbit right along the back here, and I know that this is 12 inches in width, so I'm going to have to change some parameters here. On the X, I'm going to have to set this at 11.25, and then the Y, I'm going to have to set this at 1.75, and then the width of the piece is going to be 0.75, and the height is going to be 13.25. Should get me there, I think. Wait, no, I'm sorry, it's 14.25. No, 13. Sorry, 13.25. Okay, so now I have my rabbet in the back, my dado in the bottom, and my rabbet at the top. Now what I have to do, so I can just copy this over, is create my indexing holes for my adjustable shelf that's going to go inside of here. Now it's not a very big cabinet, so what I'm going to do is I'm going to come over here and create the circle. And on the circle tool, I have the X at 10 inches, the Y at 6, and the diameter is at 1/4 inch, and I'm going to press create. And that gives me my little hole right here. Okay? Now on the Y, the next one is going to be at 8 inches. And as you can see, that second hole appeared. And then on the third one, I put in 10. So that gives me my 3 holes for my adjustables, and that's all I really need on this particular cabinet. Excuse me, is 3 separate heights. That'll do it. Okay? So then I'll go ahead and put in my other dimension for the holes on closer to the exterior or the front of the cabinet.